So I would imagine that if you do an experiment and then you publish the results, it has to be reviewed. In your world where you're doing something at CERN, it doesn't seem like it's going to be easy for other people to go and try and replicate the experiment to prove the results. Like, how does that work?
Yeah, also great question. So we do have a open data policy. So you can access all the data that CERN generates. I mean, it's not in the easiest format, and
Yeah.
it's complicated, but
Very
you can.
domain specific.
Very domain specific. But even like getting access to the data, like it's a little bit annoying.
Yeah.
But so there's that, and then so to publish a paper, we have to do two other documents first. First is a really like comprehensive analysis. I'm not sure what to call it even. It's almost like a little book. It's almost like a dissertation on its own. And then you summarize that into a smaller one. So let's say we're talking like 200 pages down to 60 pages, and then finally the 60 pages down to 2 pages if it's like physics letters, or maybe a little bit longer. So that's all documented. Every choice that you're making in your analysis, including the GitHub repos where the code lives, including any sort of intermediary tables or data that you have created. Everything should exist in that large analysis paper.
Okay.
So in theory, you'd be able to go and do it all and run it all and make sure that all the numbers make sense. Of course, in practice, no one else is likely to be running the same analysis. And this is why we have so many layers of reviewers. So the analysis that we did, we had every week we would meet with our physics working group and then also the physics interest group in order to update them on this is probably very boring for you, but in order to update them.
I'm curious.
But the status was, what we were working on, and why we were making the choices. And, it's not just sort of like update and go on, because like everyone's a physicist and everyone has an opinion, and sometimes you're making choices that are unprecedented, right? So for example, for the particular shape in the data that we were fitting, it's fairly standard to use a family of models that are well established. So if you read if you go back 10, 20 years and read all the Daimion papers, you're going to find this mention of the same function family. But as we were working on our analysis, we discovered that we needed to constrain the parameters within this function some more. So the existing constraints weren't working. So there was just too many degrees of freedom there. So we came up with this new method of sort of iteratively constraining the parameters that were kind of describing the same thing. And we had to go to bat for that, because it's like they're expecting us to say, oh yeah, we use this and then blah, blah, blah. But we're like, no, this doesn't work. So we came up with this thing. So, proving out that our new method was sound, that it was, not not dumb. It was doing the things it needed to do, not introducing any additional systematic error or errors of some sort. It's a process. And because no one else is going to run your analysis, you have to really convince everyone that you're doing things right.